Friends, welcome back to my channel. In this session we will see what is transistor and what is its construction, how it works in electronics, and then we will see its practical circuit. In this small circuit, simple circuit, I am using a transistor here, and we will see how it controls the circuit and how it will control the voltage. When we apply voltage, how it will work. What is transistor? Either it is a signal transistor, either it is medium power transistor, either it is power transistor, NPN, PNP, IGBT, MOSFET, power transistor, whatsoever. If we want to understand the basic for everything, I will recommend to watch this video. I never say that watch my video or like that, but if you are interested to understand the transistor, I guarantee that after watching this video you will understand the function of transistor very clearly. What is transistor? The first question. Either it is IGBT, MOSFET, whatsoever, UJT, BJT, MOSFET, complete family. Either it is N channel, P channel, enhancement, any type. IGBT. If we see in every name the word T is common. That means a three-terminal device. Any component which have three electrodes, three pins, that is called transistor. In this session we will see BJT, bi-junction transistor. If you have some idea about the triode, in a triode there was, in tube theory, there was a plate, there was electrode, and there was heater, and there was a control grid. Here we apply plate voltage, positive, ground, positive. These voltage were applied here, and here we apply some signal. This was triode, and we take voltage here. There was a resistor here, and we take voltage here, the output voltage. Input, output. The same BJT, it is replacement of this triode, this tube, and in semiconductor material the transistor replaced this technology, but the working phenomena, the working principle is the same. In this BJT, what is the structure? It is composition of one block, the second block, the third block. Two different type of materials are used. For example, this is N type, P type, N type. When these materials are placed here, if we see, it will make a junction. What is junction? The boundary between two materials. It is called junction. So here we have two junctions. When it have two junctions, it will called mono bi-junction transistor. Bi means two junction transistor. Two junctions, three terminal device. If we place one pin here, second pin here, so it is three terminal device. That is here. What is N? What is P? What is N? It is a specification of a material, N. It is a composition of two materials. When silicon or germanium, it have 4 electrons in outer shell. When it is doped with pentavalent, it have 5 electrons in outer shell. Phosphorus, bismuth, arsenic, antimony, these have 5 electrons in outer shell. When 4 plus 5, 9 electrons, when this material is developed, when silicon or germanium is doped with these materials, it will take 9 electrons in outer shell. For an atom, it needs 8 electrons in outermost shells, but it have 1 electron more than its required amount. So the number of electrons will increase than the number of protons. When protons and neutrons are in same quantity, it will neutral atom. But when electrons are more than the protons, it will negatively charge, because electron have negative charge. So we can say this one have negative charge. This material, the composition, the specification of the material will show that here are more electrons than the number of protons. So it is negative material, negatively charged material. And if we see p-type material, when silicon or germanium is doped with trivalent, at that time the number of electrons in outer shell becomes 7. So it needs 8 electrons. When in outer shell it will become 7 electrons, the number of electrons will less than the number of protons at that time. The material will have a specification that it have deficiency of electrons. That time it will become positive charged. So here is positive charge. The same here, negative, negative, negative. So it is composition of two types of materials, negative, negative, and in the center it have positive charge. Let me draw here. Negative, small clarification that I will discuss in electronics theory. The flow of current will be considered with in electronics theory. In conventional theory, the current is supposed to be from positive, but in electronics, the current movement is due to movement of electrons. It is very easy to understand the structure of the transistor. Now, what is transistor? If we see this step, we apply some water pressure here, and this is output, and this one is control. We can say from here we are emitting, we are entering something, and then we have a control here, then we have output here, that is collector, emitter, base, collector. We will see this example in our practical. When a silicon substrate, it have in two portions, n-type, n-type, two blocks of the n-type material, and there is a spray of p-type material, n, p, n. When it is sprayed, it have negative charge, it have negative charge. Simple words, here is excess of electrons, here is deficiency of electrons. When two different type of materials are placed together, when they have physical connections, what will happen? These free electrons, because it have 9 electrons in outer shell, and this material has 7 electrons. So here is one extra electron, and here is deficiency. So what will happen? This electron will jump here. When it will jump here, it will neutralize this atom. And here 8 atoms. Here 8 electrons, here 8 electrons. Before this here were 9, here were 7. Now this area become neutral. Both sides. This area is now neutralized. This center point is called junction. We say bijunction, one junction, the second junction. Now this neutral area, it is called barrier, and it is called depletion layer in both sides. Now if we look at this transistor, this area is negatively charged. This area have now very small amount of positive charge, and between this there is a neutral area, this area, and here we have negative charge. If we connect this material to a battery, how we will connect to battery? Negative, positive. When we apply negative charge here, what will happen? Because here are more electrons are here, these will try to repel these electrons, because it is a universal rule that similar charge repel to each other, opposite charge attract to each other. This negative charge will repel these electrons. But here we have a neutral area, that is barrier. Electrons need a force to move. How much that is force? That is called potential difference. This potential difference, when the pushing force, when we are trying to push something, we need a force. When our force will increase, then the resistance, this item will start moving. The potential difference is deficiency or excess of electrons. If this difference of charge will more than 0.7 volt in case of silicon, and if we are discussing about germanium at that time, 0.3 volt, 0.7 volt for silicon. These voltage will increase, so that time the amount of electrons will push these electrons, so that these electrons will come in this area, and after that here we have positive charge. This positive charge is here. When this potential difference is above than this voltage, it is called barrier voltage or depletion layer voltage, junction voltage. We say forward voltage. What are the forward voltage? That are these voltage. At that time, this 0.7 volt will cause to trigger these voltage, to move these voltage in this area. When it will reach here, it will jump this junction. When it will jump here, at that time these electrons will move towards this battery positive terminal. So we can say the current will start moving, the electrons will start moving from negative terminal to the positive terminal. It is electronic theory. When we say conventional theory, we can say the positive holes will jump here and these will reach to battery negative terminal. Because as I studied electronics engineering, so we will say the electrons are moving in this. So electrons are moving in this path. Now the electrons are moving here, but this is our base. We can say it is base and it is emitter. This is one forward junction. Now, to take a useful action from this transistor, we need to control the current. We can say when there is no current, base current, at that time its internal resistance was high. When we increase the potential difference, this junction now, we can say it is working like a resistance. To take a useful function from this device, we connect another battery with load. Positive, negative, positive, negative. Emitter to base junction, it is now forward bias. Collector to base junction, reverse bias. Why? Because this n-type material, it is connected to positive terminal of the battery. But if we see from here, negative, positive, with respect to this negative terminal, this one is more positive. When we will connect more high potential battery, what will happen? It will attract all these electrons. It will bring here. It will work like a magnet. It will suck all the free electrons to its battery pole. Now, if there is If there is no base current, we did not apply it too much voltage, our voltage are less than 0.7 volt, we can say this is positive terminal and this area is now neutral, and we sucked all the electrons here. At that time there are no electrons and this area becomes, we can say, neutral. In some sense we can say it will become positive charge. Here is positive and this area is more negative. We can say now huge amount of electrons will start to move here. Small portion of this current due to this battery and largest portion of the electrons due to this battery. Two batteries in series. It is basically voltage divider network which will be used to apply voltage. Now this current, when it is starting to move here, this is small area. Few number of electrons will move to this battery, but the large amount of current will move to this terminal because here is more positive area. This positive area will suck all the electrons because electrons are now reached here. When these electrons are reached here we created a deficiency of electrons due to this battery pole, so current will move here. For example, I can say 100 electrons, it is just for assumption, 100 electrons we are entering from here, 5 electrons will come here, 95 will move here. This is a ratio between base current and collector current. The amount of voltage applied here will determine the amount of base current, because as I said, it is a resistance. How much voltage we will apply, it will allow more current. When there is a more current, there is low resistance. When there is low resistance, more electrons will jump in this portion in base, so that we have a huge deficiency here, so more electrons will move in this area. If we will not break this junction, no electrons will move here. We can say this base is working like this control. When there are no voltage, it is fully locked, no water will flow. If there are no voltage or less than 0.7 volt, no current will flow. When we will apply 0.7 volt, a small amount of current will move here with this ratio. The collector current will flow. If we will put it to the center value, we can say I apply 1 volt. At that time the collector current will increase also. How? Because we opened the shutter here. Similarly, we open the shutter here, the current will start to move in collector. When I will move it full, for example, this base needs 5 volt at base, at that time it will say, we can say 50 milliampere. At that time this collector will give 5 ampere. This is the ratio we can say. This is for assumption. Every transistor, it have its own specifications. Now when there was no voltage, the transistor was in off state, that is called cut-off state, cut-off condition. When this tape was off condition, there was no water flow, we can say it is cut off. There is no base current, it is cut off. When we put in mid-range, what is that? That is conduction state. We can say it is allowing water but it is controlled. We can say that is conduction mode. That the water is flowing but it is controlled. Similarly, when we use transistor in audio amplifier, all the time the current will vary with respect to our audio signal. When the signal will increase, the current will increase. Base current will increase, collector current will increase automatically. When we will decrease the base current, the collector current will decrease automatically. Okay, the third condition, when we will open it full, what will happen? It will allow full flow of water. That is called saturation. At that time, the maximum water will flow. In this sense, the maximum current will flow. There is another condition. When we turned it off, still there is some time, there is some drop of water will come here. That is due to its leakage in the washer. So this leakage in the washer, we can say that is leakage. Similarly here, when we don't have base current, when we don't have base biasing here, base voltage, some uncontrolled electrons that are called minority carriers, they will cause to flow a current that is negligible. We cannot consider it. That is called leakage current. So it is ignored all the time. Transistor. When we express transistor in any diagram, we say it have a collector. This is collector, and there is one lead with arrow. It is called emitter, and this is called base. And if we see, it is looking like an English alphabet K. So this arrow, it is pointing outside. We can say it is not pointing in. Most of the time the transistor is in circular shape. So it is not pointing in, not pointing in. That means the arrow is not pointing in. It is not a definition for NPN, but it is to understand, to easily define the symbol. When we see arrow is not pointing in, that means it is NPN transistor. In NPN transistor, here we said emitter is negative, the base is positive with respect to emitter, but collector is more positive. When we see negative, positive, negative, positive, positive, so it is more positive. So this is the biasing, because it is a current controlling device. This component is used to control the current in any device, in any circuit. We can say we want to connect our load here. To control the base current, because we need to control the base current to control the collector current. For that purpose, we need a voltage divider network. Same here. I am using a potentiometer here, 5 kilo ohm, and here I am using 10 kilo ohm resistor. We will connect ground supply here, and here I will connect positive voltage. When the voltage are less than 0.7 volt, this transistor will work in cutoff state. It will not allow to pass any voltage to the load. It will not allow to move the current, so that all the voltage will drop across this transistor. When we will allow some base current at that time, if the 0.7 volt, so at that time the current flow will in this shape, in this path. The same time, this current, when it will start here, the same current will move to the load. How much we will open this shutter? Like this. It will control the current to the output side here. How much we will control the base? It will control the collector current. I am connecting positive voltage here, that is connected to this load. Positive is going from the same point to the load, and 3 terminals, base, collector, emitter, and I am connecting the load at the collector, that is here. So this pin is connected to collector. we are connecting the ground supply at emitter, that is return voltage, and the same voltage we are connecting to this potentiometer, and we are connecting positive 10 kilo ohm resistor here to give base biasing. And now I will power on this circuit. This time I am connecting 12.46 volt, and all the voltage are here at the collector. So all the voltage are from emitter to collector, and this time the base have 0.0 volt. When I will increase the voltage 55 millivolt, 100 millivolt, and I will check the collector voltage, still we have 11.7 volt. This time a very few number of electrons are moving, so that are not creating some effective work in the load. Now I will increase the voltage again in the base. We can see when we have around 600 millivolt, it is 10.6 volt. 1.5 volt is now moving to the load. Now I will increase more voltage at the base. This time 656 millivolt, and the fan is now spinning. Now we have 3.7 volt dropped across this transistor. Why? Because it is now working as a variable resistor. We are controlling the base resistance. We can see the collector voltage are also dropping and increasing. When we will allow maximum voltage at the base 700 millivolt or more, that time the transistor is now in saturation mode, because our load is not drawing too much current. This is 5 amperes transistor. If the load will draw 5 ampere current, at that time it will drop 1.4 volts, 0.7 volt for this junction, 0.7 volt for this junction. But this time our load is drawing less current, so that it is dropping just only 237 millivolts. When we will increase the base biasing, what is the biasing? That is the combination of the voltage, potential difference between emitter to base, base to collector, that is called biasing. How much we are making positive this base with respect to emitter, this is called biasing, base biasing. When we will decrease the potential, when the signal will decrease, the output will decrease. When the base biasing will increase, base current will increase, collector current will automatically increase. We can say emitter current is equal to IC plus IB. Emitter current is equal to collector current plus base current. If you have any question about this subject, you can write in the comments. MOSFET, IGBT, BJT, they are using the same technology. Just only the difference in all these items, in MOSFET, IGBT, BJT, that is the base current. In BJT, it uses a base current to start conduction. In MOSFET, that is insulated gate, that uses a capacitance, gate capacitance, that have slight difference in the definition, but the work, the phenomena is the same. I hope so this video is informative. If it is informative, hit the like button. If you have any question, write in the comments. Thanks for watching.